Okay, so in problem 1, 2.5, we are supposed to invert these matrices, and Cody says that he's having trouble with C. So which technique are you trying, Cody?
I was just trying to augment it and then do elimination.
Okay, cool. I think I haven't showed you guys one of these, so let's do it. So the technique where you augment is you take the matrix that you're trying to invert. So I've got 3, 4, 5, 7 here, right? And then instead of just writing it as a matrix like I just did, I'm just going to put an augment, and I'm going to augment by the identity matrix. 1, 0, 0, 1. My goal here is to take this thing and through some elimination, I'm supposed to end up with the idea of something over here augmented by something. Okay, what are the two somethings? What should I end up with on the left here?
The identity matrix.
Okay. So on the left, I should have the identity matrix after I'm done. And on the right,
The other matrix.
yeah, on the right will appear your answer, right? So that'll be my C inverse over there. You guys with me? Okay, and this one's probably hard because the numbers are kind of icky. You guys with me? Okay, so I need a first row operation. So what's the first thing I'm trying to zero out here? In order to get that to look like the identity matrix, where do I need to see a 0 that there is not now a 0?
At the 5 spot.
Okay, I need to get that friggin' 5 out of there. You guys with me on that? So what I need to do is I need to subtract 5 here. Right? I need to see minus 5 right there. So the way I'm going to do that is I'm going to do something a little bit wild. Well, okay, I've got a couple options. I'll give you guys a choice. We can either multiply through by a fraction, or we can divide first and then multiply through by a whole number. What would you prefer to do?
Multiply through by a fraction.
Okay. Chris. Jordan?
Divide.
No, it's all good. Let's do what Jordan says because this is what Jordan would have done, right? So in pink here, I'm going to write minus 5/3 row 1. That was not a comprehensible symbol. That's still not a comprehensible symbol, but it's what I got. Okay, so minus 5/3 row 1. If I take 3 and multiply by minus 5/3, I get minus 5. You guys all with me on that? Okay. Now I need to take 4 and multiply by minus 5/3. And this is why I would not have done this. No, it's all good. It's going to be garbage anyway. It's nasty either way. So I'm going to have minus 20/3. And then I'm going to have here a minus 5/3. And here I'm going to have 0. Right, so this is just row 1 times minus 5/3. Are you with me on that? So then this step here is going to be the new row 2 is the old row 2 minus 5/3 row 1. The book probably doesn't really lean on this notation, but some of the videos that I've got in my YouTube channel from algebra use this notation, so I'm just trying to match it. If you're wondering why I'm writing weird shit about bars. You guys all good with that thought at least? Okay, so now I need to actually just do that operation. So I'm going to leave that first row alone. So I've got 3, 4 augmented by 1, 0. I just left that alone. And now in the second row, I need to actually do this addition. So first things first, 5 minus 5 is
0.
Okay, that was the point, right? Now my next number is going to get a little wacky because it's 7 minus 20 thirds. So how many thirds are there in 7?
21.
21. And if you take 20 of them away, we're left with
1/3.
1/3. That wasn't so bad. That was surprisingly not bad. Now I'm skeptical about blaming Jordan for all my troubles. All right, 0 minus 5/3 is, I'm pretty sure, minus 5/3. 1 plus 0 is, let's see, if you have 1 sheep and someone gives you no sheeps, how many, let me see, carry the 0? And then you have, good, 1 sheep. Okay, so now what's your next plan?
0 out the 4.
Yeah, I need to 0 out that 4. Before I do that, I am going to multiply that second row through to get a 1 there. Because I am tired of dealing with fractions and I don't want to make my life worse. You guys all good with that? If it was more convenient for me to do this kind of addition process now, I would go ahead and do that. These 2 steps don't have to happen in this order. This is just convenience for me. So my next step is going to be that the new row 2 is 3 times the old row 2. And so that's going to get me 3. Oh, I need a little more space than that. Why do I keep doing that? That's going to get me to 3, 4 augmented by 1, 0. And then this row multiplying 3 by 3 is going to give me 0, 1, minus 5, 3. Pretty good with that? I hope this process seems a little time consuming. It is. Calculators are your friend. This is why God invented symbolic math solvers. Or whoever invented Wolfram Alpha. Okay, so next step, I'm going to now target that 4. So what am I going to use to target that 4?
4 times row 2.
Good. So I'm going to, right here, I'm going to write minus 4 row 2 in pink. So that's going to be 0 times minus 4 is 0. 1 times minus 4 is minus 4. 5, wait, negative 5 times negative 4 is 20. Because if you have 5 anti-groups of 4 anti-sheep each, that is, yeah. Okay, and then this is minus 12 here. So now my next elimination step is going to be that the new row 1 is the old row 1 minus 4 row 2. And that's going to get me to, well, I'm going to leave that second row alone. And in the top row, I just need to do this addition. So I've got 3, 0, 21, negative 12. Everybody on board with that? Okay, what's my next step?
The 3 a 1.
Good. Yeah. So I'm just going to take my top row. So the new row 1 is going to be the old row 1 over 3. Really, that should be times a third, but I'm kind of lazy. So I'm going to get 1, 0, 7, negative 4, and 0, 1, negative 5, 3. Guys, good with this? Okay, what's my last step here?
Label A inverse.
Good. I'd probably label C inverse since the matrix I started with was called C, but you know. That's especially important in here because there actually was a different matrix A. All right, so in this case, I'm going to label C inverse, and I'm going to say, all right, so C inverse is 7, negative 4, negative 5, 3. You just having trouble with arithmetic, Cody?
I got lost when we started augmenting the matrix, and it wasn't like equal to another matrix for the elimination part, at least. Like I understood going to the triangular method and then
Okay, so maybe a good second would be spent on why in the hell does this work? Is that maybe the kind of underlying question here?
yeah, I was just messing up on the arithmetic.
Oh, okay. So the why this works is if we think about having if we have an equation like ax equals b, right? You guys kind of with me on this? I'm really kind of thinking, okay, if I want to solve this equation, right? One thing I can do is I can augment and then row reduce, just like we did here. The weirdness is there's 2 rows, right? Or 2 columns, really. Sorry. So there's 2 columns in my thing. So what I'm thinking is not quite ax equals b. I'm thinking kind of a times something equals I. Right? And I'm solving for what goes here. You guys see how that process works? It's a little bit weird to think about that like, oh, the thing I'm solving for is a little matrix. And the way I'm getting it is I'm taking the equation a times something equals I, and I'm treating this something now as a 2-dimensional object instead of a 1-dimensional, as a 2-column object instead of a 1-column object. But the thought process is the same and it works the same way. You guys all good on that? Okay, cool.
I haven't started 2.5 yet, but would the method and thought process be similar in a 3x3?
Yeah,
and also, does it have to be square?
Matrices do have to be square to have an inverse. That is true, and that's because an inverse matrix is meant to be an inverse function, and it won't. There's some properties of matrices that will make it so it doesn't make sense if the dimensions of the domain and the range don't match. That's a little bit subtle, and we're going to get there in a bit. For right now, it has to be square.
So just because you said that it's like an inverse function, if you had like your row picture and you had your like something x plus something y plus something c, and you found the inverse of that function, would you then be able to find an inverse matrix of multiple functions?
Yeah, so one thing that's a little bit subtle here is I keep flip-flopping between the idea that a matrix is a function and a function is a matrix. That's true, but it's not really an evidence here. So the thing that's not in evidence is that every function has a matrix. That's not actually, so one, that's not true in general, right? Like they have to be special functions to have matrices. But even then, it's something we're going to talk about at the very end of the course, where we're going to actually prove that every function of a certain form actually has a matrix. For right now, what you can know is that a matrix is a function. That we went through, and that I think has been demonstrated pretty well, despite YouTube commenters. Someone on my YouTube channel got very confused one evening and started telling me that I was wrong, which was fun. Because like sometimes I am wrong. Like there are certainly videos where I'm wrong. That was not one of them. So you know, whatever. What we have is we have a matrix is a function. What we don't necessarily have is that every function has a matrix. So it, in our viewpoint, it could be that we could take a matrix, consider it like a function, find that function's inverse, and then maybe that function wouldn't have a matrix. That's actually possible still in our, like, given the facts that we know, that could still happen. It's not actually the case. They do all have inverse. They all have matrices, and those matrices are unique in a reasonable way. So it wouldn't, like, that is a viable method, but it's not a method I know works right now. Does that make sense? All right, cool.